So good evening, students. Why you people are joining very late? Okay, so open the same file and upload the data set. And see, I don't think everything is required except this one. Okay, I'm pasting the, like earlier, many of you asked me to share the recordings. I have shared, and did you work on it? Let me know those who are asked me to share the videos or links. I have uploaded the links. I have sent you the links. So let me know you have completed or not. Yes. Okay. Good. So I'm running this, executing this. Then all these things already we have completed. I am not going to execute. Though you are not executing, you will not have that much impact because you are not dropped anything, you have not deleted anything. Simply you are checking. And let me see how many columns I have. Same columns. And checking the value counts. Yes. Straight away, I'm moving to the label encoding, which I have explained you in detail what exactly this one. Label encoder, you want to use it here as LE. With this LE name, you want to use your label encoder. And see, before label encoding, what exactly the result if you are displaying the count and all. And after label encoding, what you are getting the output, that also you are cross-checking here. Simply you are comparing before label encoding and after label encoding. So once you display the before label encoding, then you are transforming the particular column. So you are saying LE dot, LE is label encoder, LE dot fit transform. Fit transform means you are transforming the, like you are asking to transform that to a particular range. Either it can be any kind of range. Mostly it will take the dictionary orders. Okay. You're transforming your data frame. In that data frame, you have a column called country, and that country you want to transform. Okay. So after transformed, what is the result? That you are cross-checking here in label encoder. Then coming to your method 2, before replace. So here I have used a particular function called label encoder. Here directly I'm like, for one thing you have used a model, the other thing you have used like manually you are doing. So here you are manually transforming no with 0, S with 1. So as soon as you have transformed, you will be getting the same result. But where it will be the problem means if you have multiple data, as you have only 2 attributes here, that may not be a big issue. But when you have 20, 25 or 50, you may miss 1 or 2 also, you'll be getting errors. Okay. If it is 1000, if it is 100, if it is 150, whatever the number it may be, if number going on increasing, transforming the character data to number data using this method will be very tough, will be more complicated. Okay. So for that, generally we'll prefer to go for method 1. Then see, your shape is still same. This already I have explained you, but again I'm just revising the things. Okay, so I think I have not changed this NaN value. So let me go back and execute that particular data. Because this NaN value will never accepted by the machine learning models. This one. Already it was transformed. So if you want to remodify your data means execute this again, Then I'm modifying it. Then I'm modifying this. I got the same. Then performing label encoding and method to on purchased. Then see the shape and the data frame. Now there is no character data and no null values in my data set. As of here, everything is clear, I hope. Then we have another important concept, Amma, but generally when I'm saying this as an important, people what it will do means, whenever they are performing any machine learning model, they are, these are the few steps you need to blindly remember. As of now, what we discussed, like uploading data set from there to till now, whatever we were discussed, that is common. Whatever the model it may be, for that model, these are the steps you need to remember at any cost. I hope you are able to understand what exactly I'm trying to convince you. So these steps are common. You have to follow the steps blindly whenever you are performing any machine learning model or any predictions using any machine learning model. When your data, either it is available data or you have created the data by like based on certain questionnaires and all, whatever the scenario it may be, um, data set, as soon as you have created the data set, that data set, once you have uploaded to the Jupyter notebook or Spider or like Python ideal, anything, or it can be your Google Colab. After that, all these steps you need to like you need to work on it. Okay. Then here we have a concept called one-hot encoding. Using this one-hot encoding, what happens? You are now like complete character data you have converted to number, but still the range bound is little different. It is very tough to plot, tough to predict, tough to organize. Okay. So to solve that issue, what you are doing, you need to fit that data into a certain bound, maybe like upper and lower bound. You need to get that data into a particular range. Then only it will become easier to us to plot. So to get that, we are using one hot encoding. Okay, one hot encoding is the concept where it will bring the entire data, whatever the data, that data in, like here also you have to mention a particular column. That column data will be brings into a particular range. We will see how it will perform. See here, you are importing label. Like in earlier case, you have imported label encoding, and this case you are importing one hot encoding. This case, like you are importing one hot encoding, and here we have two columns. Sorry, two attributes, two parameters. This is one parameter, and this is another parameter. We have two parameters here. So here you are using one hot encoder. So to get this, we require an object. Using this object, you are going to call this one hot encoder. So this is an object name. It can be ON, it can be OHE, it can be ONE, it can be something. It can be something you can write. You can write your name also. Because it is a name, object name. So our attribute name, or you may say object name, this object is used to call this particular method called one hot encoding. Okay. And again here, which column you want to pass to this one hot encoder? That column indexing has to be given. As I want to pass column 0, which is country. I want to pass column 0, which is country. Okay, now I passed here column 0, one hot encoder on, remainder is equal to pass through. Then you are fitting that into the, like fitting and transforming the data once you have performed this one hot encoding. Then df dot shape. See here you have 10 comma 4, but here you got 10 comma 6. I think I have explained you why you got 10 comma 6, but let me re-explain this 10 comma 6. So how this 10 comma 6 is coming means, anyway we have 4 attributes. What are they? Country, here we have, right? Age, salary, purchased. Country A, salary, purchased. We have 4 column names. Country A, salary, purchased. Now what happened? So when you are performed one hot encoding called OHE, okay. So which column you passed there? You passed country column. As soon as you have passed country column has 3 unique names. So according to our numbers, we have 1, 2, 0. We have 0, comma 1, comma 2. We have three unique names in your country. What are they? Spain. First we have France, Spain, Germany. France, Spain, Germany. Okay. So France is 0. Germany is 1. Spain is 2. This is what indexing has been given. Because I told you, it will follow dictionary order. So for the first row data, we have country as 0. When we have country as 0 means which is France. So what happened here? The first data will becomes. So all these 3 individual data or standalone data or individual data like values will become the column names. So country will go now. What you will get? France, Germany, Spain, age, salary, purchased. So this is what your data set. France, Germany, Spain, age, salary, and purchased. So when France is like the country is France means what? Here you'll get 1. Germany and Spain will 0. I'm not modifying any other content because in my syntax, I have written remainder is equal to pass through. As we have 2 attributes. Again, the first attribute is divided into 3 attributes. Okay, like that. The second attribute of one hot encoding is remainder. So remaining what all the columns you have, those columns what exactly you want to do. You want to draw, you want to pass through, what exactly you are like expecting over there. So now I don't want to drop all the columns. I want to pass all the columns as it is, and I just want to do the changes only on country. So only on country I want to do, so that what happened, the country has three different values or three unique values. Those three unique values will becomes the column names now. Country will go off and these three columns will like three row values will becomes your column names. And as those are column names, what happen? So how to fill the data of those columns mean this is the syntax. Okay. When France is there, Germany, Spain is 0. And when Germany is there, France, Spain is 0. And remaining content will be as it is. You don't want to modify, right? You want to pass through. So you are simply passed it. And if it is Spain is there, then remaining will be 0. Like that, he will fill or we need to fill this data. So now see the data frame. So it is 10, 6. See here we have 1. Here we have 1 because the first country is Germany. Next we have 0. So, sorry, first country is France. So remaining are 0. Next second country, we have Germany. So this is 0, this is 0, this is 1. Next country is Spain. This is 0, this is 1, this is 0. Like that, it will follow the entire. Okay, complete. And one more thing here, it happens like it will convert data frame to arrays. Now, if you want to perform any task, again, you need to get back to your data. Like this result, whatever you receive, these results, you want to make as a data frame. You cannot perform certain actions on series. So that is what feature scaling. Feature scaling means what? Now you are scaling. You want to scale up the data or you want to bring the data into a normalized form. Okay. For that, this feature scaling is required. You are going to scale the entire. Like here, I'm using standard scalar. So the standard scalar, using this, you want to fit your or you want to transform. You want to transform to certain range. So this will like it will brings the data into a certain range. It can be negative, it can be positive. Okay, but it will maintain the entire data into a certain range so that graph or plottings will become easier. And data like machine learning models will expect, some machine learning models will expect this one hot encoding is also done. Some may not expect, but some people are expecting. Still, you need to bring your ratification. Okay. So this is what data frame, and this is train, test, and split. So once you brought the entire data into a particular data frame, this is an array, right? Now I want to convert this array to a data frame. So I'm converting x is equal to pd data frame df. So this is what still the data frame name is there, but this is an array. So I'm converting that to 0:5. Column names are France, Germany, Spain, a salary. And that I want to display. See, this is what our data. I'll give you little time, complete this. I hope everyone completed this part. Yes? Let me know, yes or no. Little fast, Amma. We need to complete this, at least this part today. Okay. Then what happens? Now this becomes our x value. For any plottings, what we required? We required x and y values, right? What will be your x and what will be your y? Okay. So we have decided what is our x. X is our 0 to 5 columns. See here we have only 5 columns. We don't have our sixth column, which is purchased. So here in the output, we don't have purchased. We have France, Germany, Spain, age, salary. But I did not mention any purchased column here. Okay, now this purchased column is my y value. If these are your x values, and what is your y value? Okay, if all these x values you are assigning, like to get your y value, and this is what your x and this is what your y value. Okay, now we have decided what is our x now, and the remaining one is your y. See, this is what my y. So all rows, comma, we have discussed this part when we are discussing our basics of your Python. So column, so you may ask, madam, why are you explaining all such things there? Means, so due to this. See, column means all the rows, 0 is to 5. Means what? 0 is to 5 means from 0th column to 5th column. Now, here you are saying all the rows, comma, 5th column to further. As this is the last column, you don't have any further column in the next. So, only this column will be taken as a y. Complete, ma. Now division. Now the complete data set. Let me show you one PPT. Let me show you the PPT. Just a second. Actually, a very good concept, Amma. Just 2 minutes, I'll show. Data test, like testing and training divisions. Generally, people will say 80:20. Yeah, this is the very good diagram. To explain you. I hope screen is visible. Is it visible? See here. So whatever the data set we have taken, that will be this one. This is what your original data. So people will say that 80:20. Means what? So this becomes 20. This becomes 80. So 80% of your data will be taken as training data. 80% of our data is taken as training data. 20% of our data will be taken as testing data. 80% is training data, 20% is testing data. Because, so lot data, like much data or huge data we need to use to train the model. So how much data you are taking to train the model, that much accuracy you will get. Okay. Like how much time you are investing on the kids to train them to write the alphabets, that much easily or fastly they'll able to learn it. The same principle here, when you are making them to learn, when you are training training the machine to predict something, what you need to give? You need to cook up or you need to feed much more data to the model so that it will be able to predict certain results. Okay. So due to that reason, generally people will follow either 80% or among the entire data or 70% among the entire data will be used to train the model. But what happened, for example, here 1 to 100. So this is 1 to 100 I have the data rows. So I made here 80 of this is as a train data, 20 from here is test data. If you are going to divide like this, you may face the problem because you have a manufacturing company and you are able to read the data, like how much fast a machine is able to produce the packets of something, or how much gap it is taking, like it has certain problem, maybe technically or uh, whatever, maybe technical issues. We may call here technical issues. Okay. So, like with how much gap it is taking the technical issue. So from one issue to the other issue to raise up. So how much gap it is taking? Like every technical error, as soon as it throws some technical error, that technical error will be captured and put it in the system as a data set, time, including time, date, slots, all together. It will be able to read the data. So initially what happened, you may like due to certain problems, due to power cut, due to something, you got certain problems. So top 80 problems are like when you have divided 80% and 20%, top 80% data are belongs to power issues. Due to power issues, power fluctuations, it throws some technical issues. Later, what happened after 80 errors or 80 readings has completed? Next 81st reading, when it is reading, so due to some software issues, in the machine, it started throwing the technical errors. So now the topmost 80% is data when you are taking, so that data you are using to train the model. In what way you are training the model? Based on the power issues, based on the power issues, whatever the problems it got faced, that data you are used to train the model. But remaining 20%, when you are used to test the model, which is completely unknown to that, like how it will be, like means you have learned complete semester, you have learned a particular syllabus, but when you have gone to the examination room, the syllabus is unknown to you, the question paper questions are unknown to you, because they have taken some other syllabus to frame the questions. Then what happens? What is your scenario? Definitely you may be in trouble, right? What exactly you have learned? No question, no answer maps to your question. Then you will be in trouble, right? The same way happens here in the machine. The training has been done in a particular cases or particular readings. When you are gone to the testing is based on certain data, and this data which is unknown to this. So once software errors comes, how to resolve it, it doesn't know, because you haven't trained it. So likewise, that issues will be there. Or otherwise, I'll take you some other examples. This is a COVID data set. You have taken COVID data set. So top 80 cases are negative. Maybe someone has fever symptoms, someone has cough, someone has both, someone has something. So based on those symptoms, when they have gone for verification or cross check, they got negative. So top 80 results are showing negative results, and bottom 20 rows are showing positive results. If this is mixed with this and this is the symptom, you will be getting positive. So you have trained the model in terms of all negative results or all negative data or data attributes. And when you are going for testing the data, you have given positive attributes or positive values, positive X values, which are unknown to that. Definitely your results will not be properly, like you won't get your proper results. So to avoid such, you should not decide that topmost 80 or bottom 80 is so and so trained data, top 20 or bottom 20 will be the trained test data. Rather than doing like that, we have a concept called randomly selected rows. So in this randomly selected rows, what happened? So as the count may not missed, 80 is to 20. This 20% randomly one row will be picked up. Maybe 10th row, maybe 15th row, next 18th row, next 20th row, next 28th row, next 30th row, 35th row. Like that, it will be chosen randomly. And that chosen data will be kept in the test. See, randomly they have chosen, and all together, like this blue color or which have not chosen, that will be gone for training data, which are chosen here, that will becomes to the testing data. So generally you have to follow these kind of things. Where is our module? Yes. So here I have x values and y values, right? Both the things I'm taking in terms of training and testing. X train, x test, y train, y test is equal to. Now you are splitting your data. How you are splitting? In terms of x and y. In terms of x and y, and the text size is, what is the text size you mentioned as of now? Which is 20%, right? That is what you are mentioning here. Test size, test underscore size is 0.2. Random state is equal to 0. Random state means every iteration you want to, like, like this it was chosen. Randomly some 20 values has been chosen from the data set. Now all chosen values you kept in a particular place and you called it as testing data. Then what happens? Here, as soon as you, like, every iteration you want to take common test data and common train data, then your random state will become 0. You don't want to change your random states. But if you want to change it, if you want to change every iteration, I want to change my x and y values using random state. Then you can write over there 0.1. Execute this. Check your DF shape and print your shapes. X train, X test, Y train, Y test data. Okay, execute this. Students, have you completed? So this is what data wrangling techniques. Okay. This is what data wrangling techniques we have done. So tomorrow we'll start neural networks. So be on time. I'll explain you what exactly neural networks. From there, from tomorrow onwards, what we'll have applications. Okay. We have applications. We'll work on, like, tomorrow we'll have theory part. If possible, I'll start the hands-on. And every theoretical concept we have hands-on. Okay. So be on time. We'll discuss the things, and let me know if you have any doubts.